Hi, so this is our last video for our review for our Algebra 1 final exam. So if you've made it to this video and you're almost done, then congratulations. Hopefully you understood everything. All right, so let's do it. Let's do the last one. All right, so we're trying to simplify the square root of 20. And in order to simplify the square root of anything, you know it's simplified when there is nothing left in here, when there is no factor on under the radical that has a perfect root. So in this case, square root. So the way I like to do it that I find to be easiest is to try and figure out what that largest factor of 20, in this case, the largest factor of 20 with a perfect square root. So I believe the largest factor of 20 with a perfect square root is 4. So I'm going to break up 20 into its factors with 4 and whatever multiplies by 4, and in this case is 5, and that is still root 20. I have not changed the value of this expression. All right, so I can actually break that into two pieces. It's actually root 4 times root 5. Now, can I find the square root of 4? Absolutely, super easy, no calculator needed. The square root of 4 is 2, and that's why I chose that number in the first place. But can I find an easy, nice, simple square root, perfect square root of 5? No. And for that reason, instead of finding the square root, I have to keep it as it is, as radical 5, square root of 5. And that here is our answer. All right, so same idea here. I'm looking for the biggest factor of this that has a perfect square root. Now, I could choose 45 and 1, but that doesn't help at all. So ignore that I even said that. So the biggest factor of 45 with a perfect square root is 9. And I'm not changing the value here, so 9 times 5 will give you 45. These two things this thing I wrote is the same as what was given. It's just in a different form. Now I can go ahead and break this up into root 9 times root 5. Again, it's the same thing. Now the square root of 9 we can easily find. So once we find the square root of 9, we don't have to write the radical. So we have 3 times root 5, because we cannot find the square root of 5 as a nice simple number. All right, so let's keep moving. Now this one, the biggest factor of 80 with a perfect square root is 16. A lot of people broke this up into 20 and 4, which could work, but then it's not finished. And so since a lot of people broke it up into 20 and 4, I actually want to show you how it would work if you did that. So if you had 20 root 4, and don't forget the x, so I'm not changing the value here. 20 times 4 times x, that's 80x. All right, so we can easily find the square root of 4, which is 2. We cannot easily find the square root of x, so we have to keep it under the radical. So it's root x. Now ask yourself, is this fully simplified? You know it's fully simplified if it does not have a factor with a perfect square root, but it does have a factor with a perfect square root, and that factor is 4. So rewriting this, it becomes root 4, root 5. We actually did that question earlier, right up here. All right, so now we can actually keep going. 4 does have a perfect square root, so we would write that there. It's 2, no radical because we already found the root of 4. Radical 5 because we cannot find a nice simple square root there, times 2 times root x. Now our commutative property says, we can take this, we can move it over there, it looks better over there. So it's really 2 times root 5, root x. Let's group things. That would be our associative property, right? So we have 4. Now you don't have to know the properties for this exam. I'm just trying to reiterate things that were important and still are important, but just not for this exam. All right, and I have a little problem here. This should actually be under the square root sign. And now we're good. Okay, so a couple more. This one and the extra credit. I definitely want you to understand the extra credit one as well. All right, so a lot of people messed up on this one, which was a little bit sad because it was the easiest one on the page, but you didn't know that probably. Remember, you're looking for the biggest factor with a perfect square root. In this case, the biggest factor of 64 with a perfect square root is 64 because it does have a perfect square root. So we're going to find the square root of 64. We're going to find the square root of v squared, which is also pretty easy to find. So the square root of 64 is 8. No radical necessary because we've square rooted it. The square root of v squared is just v. Again, no radical necessary because we've square rooted it. That's the answer. All right, so I found the extra credit to be pretty fun, so let's go over it. All right, so you want to have, again, the biggest numbers with a perfect square root. So with the numbers, I think you guys have gotten quite used to it. I'm going to break it up all under one nice big square root sign. We have factors 196 and 2. And if you're not good at finding it, you might want to just think about what your perfect squares are. 1 squared, for example, is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. And they jump up pretty fast. 5 squared is 25. 6 squared is 36. So on and so forth. I'm not going to go through all of that. All right, so the biggest thing here with a perfect square root, the biggest factor of that with a perfect square root is the even number that comes right below it. So m to the 4th. But we can't just drop that one m to the 1st. We have to write it as well. So that together is m to the 5th, but I just broke it apart just like we broke this apart. Now I'm going to break apart the n to the 4th if necessary, but it's not because n to the 4th is actually already a perfect square. So I'm just going to leave it there. But I do have to break apart the p to the 5th. And so I'm breaking it apart. P to the 4th is a perfect square. And p, we have to multiply by that so that we now have p to the 5th. All right. And really, we're taking the square root of everything. So I'm going to just break everything up. I'm just rewriting it, but with the radicals separate. And again, this is not necessary. This is only for the sake of me explaining it and being absolutely, totally clear. And there's a little bit more. And there we go. All right. So ask yourself, does 196 have a perfect square root? And it does. The perfect square root is 14. Does 2 have a square root? Well, not a perfect one, so we have to leave it under the radical. Does m to the 4th have a perfect square root? Absolutely does. It's m squared. It's always half the index if you're doing square root. We divide it's always half the exponent. So we divide the exponent by the index of 2. That's how we got m squared. But m does not have a nice, wonderful root, so we keep it under the radical. The square root of n to the 4th is n squared. Square root of p to the 4th is p squared. And the square root of p, not a nice, simple thing, so we leave it under the radical. Now we can group everything that's under the radical together. And so we get, all right, and everything that's not under the radical, we group those together. 14 goes with m squared, which goes with n squared, which goes with p squared. And then under the radical, we have 2mp. That was way too long, so let's adjust that there. All right, and so now we have our answer. And that was the last question that we were going to go over. So hopefully this review helped. This should be everything you need to know for your Algebra 1 exam. Good luck, and I will see you in my next video.